Question 13a. Unpolarized light with intensity I in equals 5.15 watt per meter squared passes through two polarizers. The emerging polarized light has intensity I out equals 0.562 watt per meter squared. What is the angle between the two polarizers? So here we have an unpolarized light of intensity I in, and I in they have given us to be 5.15 watt per meter squared, and it passes through two polarizers. Let us call them polarizer 1 and 2. The angle between these two polarizers be theta. The emerging polarized light has an intensity I out, which is 0.562 watt per meter squared. We need to find what is the angle between them. So we need to find this angle theta between polarizer 1 and polarizer 2. So let's assume that polarizer 1 is vertically aligned and polarizer 2 is making an angle theta with the vertical. When an unpolarized light passes through polarizer 1, only the vibrations which are aligned in vertical axis will be allowed to pass through. Horizontal vibrations will be blocked. So the light coming out of polarizer 1 will be half of the original intensity. So we can write I1 to be the intensity of light coming out of polarizer 1, and I1 will be half of the initial intensity. Then this light falls on polarizer 2, and since this is a plane polarized light, when it passes through polarizer 2, we will find its intensity I2 using Malu's law. I2 has to be equal to the intensity which is coming out, which is I out, and that can be found using Malu's law, which is given by the rule I2 will be equal to I1 cosine square theta. So we can write I out to be equal to I1 is I in by 2 cosine square theta. I out is 0.562. I in is 5.15 over 2 cosine square theta. I need to find theta, so we will rearrange the term to leave cosine square theta alone. So we get cosine square theta to be equal to multiply with 2 on the other side and divide with 5.15. So 0.562 times 2 over 5.15. Now take the square root on both sides. Cosine theta will be square root 0.562 times 2 over 5.15. That gives you 0.467. I want to find the angle theta, so we will take cosine inverse of this term. So theta will become equal to cosine inverse of 0.467. That will become equal to 62.16 degree. So this is the angle theta between the two polarizers. Question 13b is similar to A. Again, we have two polarizers. I will call them 1 and 2. Unpolarized light of intensity I in, which is 1.87 watt per meter squared, is incident on these polarizer, and the final intensity coming out of polarizer 2, which is I out, is 0.383 watt per meter squared, and we need to find what is the angle between these two polarizers. So we need to find what is the angle theta. Again, we assume polarizer 1 to be vertically aligned and the path axis of polarizer 2 making an angle theta with the vertical. So when an unpolarized light passes through polarizer 1, only vertically aligned lights are passed through, only vertical vibrations are passed through, all of the horizontal vibrations are blocked. So the intensity of light I1 coming out of polarizer 1 has to be half of the original intensity. Then this light falls on polarizer 2, and the intensity coming out of polarizer 2, which will be I2, can be found using Malu's law. So we can write I2 to be equal to I1 cosine square theta. I2 is nothing but the final intensity coming out of the two polarizers, which is I out. So I can write this as I out equals I1 is I in by 2 cosine square theta. Now let's substitute the values. I out is 0.383. I in is 1.87 by 2 cosine square theta. Rearrange to write in terms of cosine theta because we need to find the angle theta. So we get cosine square theta equals 2 times 0.383 over 1.87. Since we want theta, let's take square root on both sides. So cosine theta will be square root 2 times 0.383 over 1.87. That gives you the value of cosine theta to be equal to 0.64. Since we want to find theta, let's take cosine inverse. Theta will be cosine inverse of 0.64. That gives you the angle to be equal to 50.2 degrees. Question 13c says, when an unpolarized light passes through a Polaroid filter, what happens to the vibration direction and the intensity of the transmitted light? Now, whenever an unpolarized light is passed through a filter, only the vibrations which are aligned to the pass axis of the filter are allowed to pass through. All the other lights are blocked. So let's say if I have polarizer 1 here and its pass axis is vertically aligned, when an unpolarized light passes through polarizer 1, only vertical vibrations are allowed to pass through. All of the horizontal vibrations are blocked. So this light now becomes plane polarized. Plane polarized means it has vibrations only in one plane or only in one direction. So we can say that the vibration directions become polarized. It becomes aligned to the axis of the polarizer, and the intensity of the light will reduce. Like in case of polarizer 1, when unpolarized light passes through it, since its axis is vertically aligned, the intensity here, if originally was I naught, I1 will become half of I naught. If it was passing through any other angle, we use Malu's law. And again, when the light comes out of any other Polaroid filter, if the Polaroid was not vertically aligned or horizontally aligned, if it were making an angle theta with the unpolarized light, we would be using Malu's law to calculate intensity of the transmitted light, which is given as I equals I naught cosine square theta. And this intensity will again decrease when it comes out of the Polaroid, whereas the vibration direction will be the same as the pass axis of the Polaroid. So if the Polaroid was making an angle theta, the light coming out of this Polaroid will also be making an angle theta with the vertical.